Daphne Carroll. I am the instructional coach at Minor Elementary School. This is a video tutorial to help parents and students understand a strategy that we teach young learners to help them with long division. It's called the partial quotient method, and this method is a strategy that you as a parent may not have learned growing up, but it really helps our students to increase their number sense, think about number, and be successful at long division long before they may have memorized all of the multiplication facts. So I'm going to attempt to show you how we would teach our students to use this strategy so that you can help your students at home with homework and answer questions that they may have. So the partial quotient method begins by looking at a division problem. We're going to start with something basic, a basic fact that maybe our third grade students haven't mastered yet, but could get there by some of the prior knowledge that they have. So let's start with a basic fact. Let's say 72 divided by 9. Now with partial quotients, we like to teach the students to make this long line down the side to keep track of their thinking. As a matter of fact, some teachers like to call this strategy the Big 7 because it makes the shape of a 7. So once we have our long line drawn, we need to think about this problem, and we need to think about how many groups of 9 goes into 72. Well, I'm a third grader and I may not know my basic facts, and I may not know right off how many groups of 9 are in 72, but I might remember another fact that I can use and pull out, subtract out of that number to make it easier for me. So over here on this side, I'm going to think to myself, well, I know, let's see, 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36. Oh, I even know 9 times 5 because that's a 5 fact. 9 times 5 equals 45. I think I'm going to start there. And I know that 9 times 5 is 45. So if I subtract 5 groups of 9 out of 72, then I'm going to take away 45. I like to give these problems some story context so that kids can understand what they're doing. So let's say I have 72 pencils, and I have 9 students to share those pencils with, and I want to figure out how many pencils each student will get. Well, if I subtract out 45 of those 72 pencils, I can use my subtraction skills. I know I need to go ahead and take away a 10 here so I can give myself some more 1s. So I'll change that to a 6, and I'll add my 1 to make 12. 12 minus 5 is 7, and 6 minus 4 is 2. So that leaves me with 27 more pencils that I need to divvy out. Right off, I remember that 9 times 3 is 27. 3 groups of 9 is 27. So I'm going to go ahead and add those 3 groups here so that I can go ahead and subtract those out. So 9 times 3 is 27. I'm going to write my 27 here, which gives me a remainder of 0. So I have given out all of my pencils, but now I have to go back and see how many groups of 9 did I subtract out, because remember, division is just repeated subtraction. So first I subtracted 5 groups of 9, and then I subtracted 3 more groups of 9. So I know that together 5 and 3 make 8. So if I had 72 pencils, and there were 9 students that I was sharing those pencils with, then we know now that each student would receive 8 pencils. So that was a basic fact for division that you could use with the partial quotient method to help you to solve one that maybe you haven't memorized. But let's go and look at a harder problem here that also uses partial quotient, or we can use partial quotient. Okay, so we're going to use this strategy again. This time we are going to use a 3-digit dividend. So let's start with 457 divided by 3. All right, so I know right off that this is going to be a harder problem for me, and partial quotient's really going to help me to be successful with this problem. Before, I have learned the algorithm for long division, which requires me to have a lot of basic facts memorized. So with this 3-digit dividend, we're going to be using repeated subtraction just as we did in the previous problem, but I like to encourage my students to think of friendly numbers that we know, and this really increases number sense as well. So I don't know how many groups of 3 are in 457, but I do know that one group of 3 is 3, and I know that 10 groups of 3 is 30, and I know now that 100 groups of 3 is 300. So we're going to think about 300 subtracted from 47. That's a nice big chunk I can take out. Okay, so I'm going to take 300 and I'm going to write that here so I can subtract that out. And let's give this problem some context. So let's say that I have 457 t-shirts, and I need to distribute those t-shirts to 3 stores. How about Walmart's? So I need to find out how many t-shirts each of those Walmarts is going to get. So we're going to go ahead and subtract out 300 here. And what's really nice when you use multiples of 10 is you really don't have to regroup here. So it's extremely easy to subtract without making a computation error. So I'm just going to go 7 minus 0 is 7, 5 minus 0 is 5, and 4 minus 3 is 1. So that leaves us with 157. Well, let's see, I have 157, and I like to tell my students to think about the first number. How many groups of 3 goes into 1? Well, there are no groups of 3, so I need to go on to the next number, but I do know that there are 5 groups of 3 in 15 because I have memorized that 3 times 5 is 15. So I am going to go ahead and think about that fact. But if I know that 3 times 5 is 15, I also know that 3 times 50 equals 150. So I'm going to go ahead and subtract out that nice big chunk because that's really close to 157. So I'm going to subtract 150 t-shirts out of the 157 I have left, which leaves me with a nice small number of 7. Well, I know, and most students know, that there are 2 groups of 3 that go into 7. So I can go ahead and subtract out those 2 more groups of 3, which equals 6. And that gives me a remainder of 1. So I can go ahead and write that I have a remainder of 1 up here, but I need to figure out how many t-shirts altogether each Walmart's going to get. So first I multiplied by 100 groups of 3, then I multiplied by 50 groups of 3, and then 2 more. So if I add all of those up, I get 152 t-shirts with 1 lonely t-shirt remaining. So you can see how partial quotient helps the students to use what they already know about number and multiplication to solve more difficult long division problems without using the standard algorithm, which they really don't need to use and learn until 6th grade. I'm hoping that this helped you out.